lecture 42, compound gas law sample problems. Our first sample problem is a gas has a volume of 800 milliliter at negative 23 degrees C and 800 torr. What would the volume of a gas be at 227 degrees C and 800 torr? So since we're talking about compound gas law, so our general equation is P1 V1 over T1 is equal to P2 V2 over T2. So if we collect our data here, our V1 will be equal to 800 milliliter, and we're asked to calculate for another volume, which is V2 is equal to question mark, and then our first temperature there, T1 is negative 23 degrees C. We'll convert it to Kelvin by adding 273. So our T2 second temperature is 227 degrees C. We convert it to Kelvin by adding 273. And then our P1 there, which is first pressure, is given to be 800 torr. And then our second pressure, which is P2, is 600 torr. So since we are interested in V2, we cross multiply. Here we will have P1 V1 T2 is equal to P2 V2 T1. We're interested in V2, so we divide both sides by P2 T1 P2 T1. So this and this will cancel, and then our formula here will be V2 will be equal to P1 V1 T2 all over P2 T1. So if we substitute our values here, our P1 here is 800 torr, and our V1 here is 800 milliliter, and our T2 here we adding 227 to 273 will give us 500 K, and then our P2 here is 600, and then our T1 we're subtracting 23 from 273 will give us 250 K. So this K will cancel this K, torr and torr will cancel. So our V2 we reduce our 0, this 0 cancel into 2 0, this 0 cancel into 0. So here we'll have 800 times 80 ml times 5 divided by 6 times 25. So if we use our calculator, we'll have 800 times 80 times 5. So we'll have 320,000 milliliter. Then we have 6 times 25 will give us 150. So our V2 will be equal to 320,000 divided by 150. So here our V2 is 2.13 times 10. 1, 2, 3, 3 10 power ml. So this is our new volume. Okay, then we get to our next question that says 500 ml of a gas in a flexible wall container are prepared at 700 millimeter mercury and 200 degrees C. The gas is placed into a tank under a high pressure. When the tank cools to 20 degrees C, the pressure of a gas is 30 atm. What is the volume of a gas? So we should recall that our general formula is P1 V1 over T1 is equal to P2 V2 over T2. So if we collect our data here, our first pressure, which is P1, is given to be 700 millimeter mercury, and our P2, which is our second pressure, is 30 atm. And then we come to our V1. Our first volume is given to be 500 liter, and they ask us to calculate for volume because they say what is the volume. So V2 is equal to question mark, and then our T1, our first temperature given is 200 degrees C. We convert it to Kelvin by adding 273, and then our T2 is 20 degrees C. We add 273, we convert to Kelvin. So here we'll have 473 Kelvin, and here we'll have 293 Kelvin. So because our pressure, our P2 is given atm, we have to convert from 700 millimeter mercury to atm. We say times 1 atm is equal to 760 millimeter mercury. So this and this will cancel. So we going to divide 700 divided by 760. So our new pressure here is 0.921 atm. So since we are interested in V2, we cross multiply. Here we'll have P1 V1 T2 is equal to P2 V2 T1. So divide both sides by P2 T1, divide both sides by P2 T1. So this and this will cancel. So V2 will be equal to P1 V1 T2 or P2 T1. So if we substitute our value, our V2 will be equal to, our P1 here is 0.921 atm, and then our V1 was given to be 500 liter, and then our T2 is 293 Kelvin divided by our P2 is 30 atm, and then our T1 here is 473 Kelvin. So Kelvin cancel out Kelvin, 18 and 18. So our V2 will be equal to, so we say 0.921 times 500 times 293. So we have 13,496.5. So we level it up, divided by 30 times 473. We have 14,190. So if we divide all two here, our V2 will be equal to, we have 13,492.6 divided by 14,190. So our V2 is 9.5 liter. So that's our volume there. So we take on our sample problem number 3. It says 690 milliliter of oxygen are collected over water at 26 degrees C and a total pressure of 225 millimeter mercury. What is the volume of the dry oxygen at 52 degrees C and 800 millimeter mercury? The partial pressure of water is given to be 25.2 millimeter mercury. So here we call out data, knowing that P1 V1 is equal to T1 is equal to, or T2 is equal to P2 V2 or T2. So let's collect our data. Our V1 there is 690 milliliter, and our V2, it also calculate the volume of the dry gas, of the oxygen dry gas. So that means our V2 is equal to question mark, and then our P1 there, which is, because they gave us the total pressure of the water vapor and that of oxygen, and we have to calculate for the P1 will be the oxygen of the pressure of oxygen. So P2 of P1 of O2 is your question mark, and then our P2 was given, the oxygen is given to be 800 millimeter mercury, and our T1 first temperature is given to be 26 degrees C. We add 273 there, change to Kelvin. Our T2 was given to be 52 degrees C. We add 273, change to Kelvin. So the partial pressure was given, and also gave us the total pressure is 725 millimeter mercury. So knowing that, so we say calculate P102. I mean the pressure of oxygen. We have total pressure is equal to partial pressure of H2 plus partial pressure of O2. And then our total pressure is given to be 725 millimeter mercury. And then our partial pressure for oxygen, for water is given to be 25.2 millimeter mercury plus PO2. So we send the 25.2 millimeter mercury across the equation term. So our PO2 now will be 7.5 millimeter mercury minus 25.2 millimeter mercury. So if we do our subtraction there, we have here 725 minus 25.2. So our pressure of oxygen, which is our P1, is 699.8 millimeter mercury. Okay, so we are interested in V2, so we cross multiply. So here we'll have P1, V1, T2 will be equal to P2, V2, T1. So we divide both sides by P2, T1, divide both sides by P2, T1. So this and this will cancel. Our V2 will be equal to P1, V1, T2 or P2, T1. So if we substitute our value here, we'll have V2 will be equal to our P1 is given to be 699.8 millimeter mercury, and our V1 is given to be 690 milliliter, and our T2, if we add 52 to 273, we'll have 273 plus 52, we have 325 K, which is our T2, and our P1 here, our P2 here is given to be 800 millimeter mercury, and then our T1, we're adding 273 plus 26 will give us 299 Kelvin. So Kelvin will cancel Kelvin, millimeter mercury will cancel millimeter mercury. So here our V2 will be equal to, we multiply, we say 699.8 times 690 times 3.5. We have 15,693,0,150. So we left with milliliter. Then here we have 800 times 299. We have 23,900. So here now our final volume will be 15,693,0,150 divided by 239,200. So our final volume is 656 milliliter. So let's take our last question, which is question number 4. And question number 4 says, here, the pressure of a gas is reduced to 75% of its initial value, and the volume is increased by 40% of its initial value. Find the final temperature given that the initial temperature was minus 10 degrees C. So here we are asked to calculate. So they say the pressure of a gas is reduced by 75% of its initial value. So what would be the initial value of the pressure? So initial value of the pressure is 1 atm. So we find 75% of this 1 atm to be our P2. So P1 is 1 atm times 75 or 100. We'll have 75 atm to be equal to our P2. And then now they also say here the volume is increased by 40% of its initial value. So what will be the initial value of P? So our V1 will be equal to 1 liter. So we'll find 40% of 1 liter, which is 0.4. So they say increase, that means the 40% plus the initial volume will be plus 1, which will be equal to 1.4 liter. So knowing that P1 V1 over T1 is equal to P2 V2 over T2. So if we collect our data here, we have our P1 is equal to 1 atm, and our P2 will be equal to 0.75 atm, and then our V1 is 1 liter, our V2 is 1.4 liter, and then our T1 here is equal to negative 10 degrees C. We'll add 273 to it, 0 Kelvin, and our T2 is equal to what? Question mark. So since we are interested in T2, we cross multiply. Here we'll have P1 V1 T2 is equal to P2 V2 T1. So we divide both sides by P1 V1, divide both sides by P1 V1. So our formula for our calculation will be T2 is equal to P2 V2 T1 over P1 T2. Okay? Or P1 V1 rather. Sorry. So if we substitute our value here, T2, our P2 was given to be 0.75 atm, and our V2 is 1.4 liter, and our T1, we're subtracting 10 from 273, to give us 263 K. Our P1 is 1 ATM and our V1 is 1 liter. So liter cancel liter, ATM and ATM. So our T2 will be equal to, so we say here 0.75 times 1.4 times 263. So our temperature is 276.15 K. So this is our T2.